test for chapter 4. Here we go. So this is the velocity, and it's the derivative of the distance, and the derivative of velocity is acceleration, and s is the distance, velocity is v is the velocity, and a is acceleration, and t is the time. And it says an object decelerates, and its velocities are given in the table. And the velocities are in meters per second and times in seconds. It says do Riemann sum right hand 6. So 1, 2, 3, 4, 5, 6, 7. But there's a rectangle there, rectangle, rectangle, and rectangle. So there's 6 rectangles. And if we're going to go the height on the right side, each rectangle is 2 wide. If I were to make a graph, 2 wide, 2 wide, 2 wide. So the widths are 2, and the height, the right side of this first rectangle, left side is 35, right side is 30. And then the right side of the next one is 15. And the right side of the next one is 6. And the right side of the next one is 5. And the right side of the next one is 3. 1, 2, 3, 4, 5. And the right side of the next one is 0. There's all 6 of the right sides of the rectangles. Each one 2 wide, so I'm going to just add these up and take it times 2. 45, 56, 59 times 2 was 118. And the units on this, since this is 2 seconds, and these are meters per second, so this is in seconds, and each of these are meters per second, so the seconds is going to cancel, and we're going to get 118 meters. Now, if we're supposed to do left 3, so we're going to divide this into 3 of them. So I'll have to do that, that, and that. So each one's going to be 4 wide, 4 seconds wide, and the height on the left side of this one is 35. The left side of this interval is height of 15, 4 seconds, meters per second, and in this one it's 15, and then the next one is 5. Got distracted thinking about the units. Okay, and so there's the 3 using the left side, and left side of these 3 intervals. So 35 plus 15 is 50, plus 5 is 55, times 4. 55 times 2 is 110, so times 4 is 220. Okay, quite a bit of difference between those two. Let's make sure I got that right. Yeah, 45, 55 times 2 is 110 times another 2 is 220. Okay, M3, which should give us probably a better answer. So I got to split it into 3 intervals. So that's what I did last time. And I want to use the midpoint for each time. So the intervals are still 4 seconds wide, and the midpoints are 30 meters per second, and the midpoint of this one is the 6, plus the midpoint of this one is 3 meters per second. This one should be better. This one is, since there's more of them, it should be closer than this one, which had less. This one has not as many, but they're in the midpoint, so it should be better. Let's see what we get out of this. 39 times 4. 39 and 39 is 78, so 156. So that's um, better. I mean, we're still in the same, somewhere between 118 and 220. And it says do T3. Well, we have to do right 3 and left 3. We have left 3 here. We need to do right 3, which would be using the right side of this one, the right side of this one, and the right side of this one. And each one of those would be 4 wide, so we'd have to do, for the right 3, we would do 4 seconds times 15 plus 5 plus, and the right side of that one is 0. So that's 20 times 4, which is 80. So T3 is the average of the T3 is the average of R3 and L3, which was B. So 220 plus 80 is 300 in half. That's 300 divided by 2, which is 150, which is close to M3. Okay, that was number 1. Number 2, we have this graph, and it says determine the low value of either R4 or L4. So which one's going to give the lower value? Using the rectangles with the left side on the curve or the right side on the curve? And so I think the left side, since this is an increasing function, the right side will be lower. And I want to do from 1 to 3, from 1 to 3, and do 4 of them. So each one's going to be a half unit wide. So I'm going to use this rectangle, then this rectangle, and then this rectangle, and then the last one would be here. And they're all under, and so it says, explain why this will be the lower sum. And that's because it's an increasing graph, and so it'll always be lower if the left side's on the curve. And now let's get our left 4. So each one is 1/2 wide. The height of the first one is, oh, see, this is 2, this is 3, so that looks like about maybe 2.2, 2.1, something like that. Plus, this one looks like about 4.3, 4.2, somewhere in there. And this one looks like about 5.5. And then the last one looks like about 5.9. So 6.5, 7, 12, 17.9 divided by 2 is 8.95. And they don't give us any units, so that's all we can do. That's kind of what I get for my estimate on that one. 3. Now, I like this problem, so expect something like this on the test. Okay, so the thickness of ice on the roof is F of T, and so the derivative would be how fast it's changing. So little f of t is the derivative of it, so this tells us the rate of change. So this says and it says the t inches in t hours after midnight. So this is 2 hours after midnight, or 2 a.m., and it's saying there was a half an inch of ice. This is saying at 7 a.m. there was 4 inches of ice. This is saying at 9 a.m. there was 5 inches of ice. And this is saying between 2 a.m. and 3:30 a.m. the change in the amount of ice is 3/4 of an inch. Okay? And this is saying between 4 and 7, the ice increased by 1.5 inches. Get how to read those? So with this information, we're supposed to answer these questions. How much did the ice increase between 7 and 9? Well, at 9 there was 5, and at 7 there was 4, so the increase is 1 inch. How much ice was there at 4? Well, let's see. Between 4 and 7, it increased by 1.5 inches, and at 7 it was 4, so if we back off, lose that 1.5 inches, we would get back to 2.5 inches. And it says, how much ice was there at 3:30? Well, at 2 there was 1/2 inch, and between 2 and 3:30 it got 3/4 of an inch. So 1/2 inch plus 3/4 more makes 1.25 inches. And this says, what was the average amount of ice between 4 and 9? So between 4 and 9, at 4 we figured out there was 2.5 inches. At 9 there's 5 inches. So the increase between 4 and 9 is 2.5 to 5, 2.5 inches in that time span, and that's over 5 hours. So how many inches did it get per hour on average? So 2.5 divided by 5 is 0.5 inches per hour. I like number 4 too, because it requires us to know a little bit about even and odd functions. Now, an even function is one that is symmetric with the y-axis, like x squared, even power, or cosine x. It looks the same to the right as to the left, or x to the fourth, or absolute value of x. Even means it's symmetric with the y-axis. An odd function is one like x to the third, which has origin symmetry. This, if you rotate it around, matches this, or this rotated 180 matches that. Same as the sine curve is an even function because this rotated 180 sits on top of that. So I've asked you to think about an odd function that's something like these, and the area under the curve between -2 and 5 is 8, and from 0 to 2 is 3. So let's make a graph and say from 0 to 2, 0 to 2, the area is 3. So let's just say that's 3. And so since that is 3 and it's odd, so whatever it does on this side does the negative on this side, it has to be negative 3 over here. Now it says from negative 2 to 5 is 8. Negative 2 to 5 is 8. Well, minus 3 plus 3 is 0. Plus what will make 8? Well, it'd have to be 8. So the area here has to be 8. And since it's odd, over here it has to be negative 8. So, how much area is there between 0 and 5? 0 and 5 is 11. Between 2 and minus 5. 2 and, oh, wait a minute, that's going backwards. From minus 5 to 2 would be negative 8 minus 3 plus 3, so negative 8. But if we're going backwards, that would turn it to positive 8. And how much area is there between minus 5 and 5? Minus 8 minus 3 plus 3 plus 8 would be 0. Okay, general antiderivative. So the antiderivative of x to the minus 2 would be, add 1 to that would be x to the minus 1 and divided by minus 1. So x to the minus 1 is 1 over x, or you can leave it x minus 1. Divided by minus 1 will make it negative. So that's the antiderivative of that. This is x to the 1/2. If I add 1, it'd be x to the 3/2. So x to the 3/2 divided by 3/2 or multiplied by 2/3. And the antiderivative of sine x is negative cosine, so the negatives would cancel and be plus 2 cosine x. And since I asked for the general, plus any constant. So you have to put the plus c on it. This one, I would take and put this x to the, this is x squared, which would be the same as multiplying by x to the minus 2. So I'd actually do that. X to the minus 2 times this would be 5x to the minus 3/2 minus, and minus 2 plus 3 is minus 1, x to the 1. So if I were to do the antiderivative of this, I'd have to increase this by 1, which would be 1 minus 1/2, and I'd have to divide by minus 1/2, so we'd have 5 divided by minus 1/2, which I think is minus 10, x to the minus 1/2, and the antiderivative of minus x is 1/2 x to the 1/2 plus c, or going on, this would be minus 10 over the square root of x minus 1/2 square root of x plus c.